This video is going to cover Unit 33, Sections 1 and 2. Trigonometry. Here we go. Okay, so 33.1 is the ratio of right triangle sides. So we know what a right triangle looks like. So we know already that this is the 90-degree angle, and these two angles are complementary to each other because all three angles add up to be 180, and if this one's 90, that means that these two are 90 together. So that means they're complementary. Now in a right triangle, the ratio of two of these sides is going to determine this angle and that angle. And also at the same time, this angle and this angle are going to determine the ratio of the sides. All right, so we already know, like I said, this is the 90, and the opposite of the 90 is the hypotenuse. Now the other two sides, what we call those, all depends on which one of these two angles is going to be the reference angle. The reference angle just means that that's the angle that you're looking at the triangle through. So if this were my reference angle, this side over here would be the opposite side because it's opposite of the angle, and this side would be the adjacent side because it's adjacent to the angle. All right, so the three sides that we have are the hypotenuse, the adjacent, and the opposite. Now the hypotenuse, like I said, is always going to be the one opposite of the 90. But if I had another triangle drawn similarly to that one, and of course this is going to be the hypotenuse. If this were the reference angle, then this one would be the hypotenuse and this one would be the adjacent. So it all depends on which angle is the reference angle that will determine which of these two sides is going to be the adjacent and which one's going to be the opposite. All right. Hey, you can see something very similar to that just a little bit below halfway on page 888. What is that page? 839. All right. So that's really all that section 1 is about. It's just talking about the sides of a right triangle. Now, so let's look at page 840, and let's just look at a couple of these examples. I'm looking at number 17. Got a triangle that'll look a little bit like this. And this is M, this is S, and this is P. This is my reference angle right here. So M is going to be the opposite side, S is going to be the adjacent side, and P is going to be the hypotenuse. So they have a whole bunch of them there. But that's basically the way it goes. And it doesn't really matter the orientation. So if you've got one that looks something like, let's pick one here, 20. 20 looks like it's in a unique situation. So we've got the 90 here. This is the reference angle. What is that? M? T, I think is what that is. And R. So this is my reference angle. Opposite of the 90 is going to be the hypotenuse. So T is the hypotenuse. M is adjacent, so that is the adjacent side, and R is the opposite side. Okay, so let's get to the trig functions that they're talking about in section 2. Okay, so if I've got a triangle, we're going to be dealing with a few triangles in this. All right, this is my reference angle, and hypotenuse, opposite, adjacent. And I'm going to name this angle theta. Okay, it's like an egg with a line through it. Now, we have three main trig functions, and those three main trig functions are sine, cosine, and tangent. All right. Then we put the symbol for the angle after that. So the symbol I used was theta, sine of theta, cosine of theta, and the tangent of theta. Now each of these trig functions is going to deal with two sides. Sine is going to be the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent. All right? So tangent of this angle right here would be this side over that side. So we have the angle is equal to, the tangent of the angle, that is equal to whatever this side is over that side. The ratio. This is the ratio. Now, with these three trig functions comes three other trig functions, and they are the inverses of these. So the inverse of sine is called cosecant. So the cosecant of the angle is equal to the hypotenuse over the opposite side. The inverse of cosine is called secant. And that is equal to the hypotenuse over the adjacent side. And then the inverse of tangent is called cotangent. Oops, forgot my angle symbol there. Cotangent of the angle is equal to the adjacent side over the opposite side. Now, about these two right here. Sine and secant seem like they should go together, and cosine and cosecant seem like they should go together too. This is one of those things in math that you're just going to have to remember that they're not what you might think they should be at first. Once you deal with them, then maybe you'll start to remember. I sometimes mess them up even today. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over the adjacent. And then these are just simply the inverses of those. Okay, so let's look at figure 33-8 on page 841, a little bit below halfway. Okay. All of these triangles we're dealing with a few triangles here. And this is angle A. This side from here to here is 1. From here to here, so that's 1. What is that one? 1.6. From there to there. And then from here all the way over to here is 2.4. What we're getting at here is the ratios are the same, and the angle, this angle right here is the same, so all of these triangles are similar. So this side right here is 0.5, this one is 0.8, and this one is 1.2. So angle A for all three triangles is the same. Now the ratio of the opposite side and the adjacent are the same as well. the opposite side is half of the adjacent in each of these ratios. 1 in 0.5, 1.6, and 0.8, 2.4, and 1.2. So all of these triangles are similar. Also, because angle A acts as the same angle, the reference angle, sort of, for each of these triangles, that means that each of these angles are all the same as well. The same as each other. So these are all tangent functions, opposite and adjacent, opposite and adjacent, opposite and adjacent. They're just showing you that if this ratio is the same between the opposite and the adjacent, they're all the same, so therefore this angle would be the same. So I could draw each of these triangles out individually, and I would still know that this angle is the same on all of them because the opposite and the adjacent ratio is the same. Because remember, the sides, the ratio of the sides determine the angle, just like the angle determines the ratio of the sides. So they work off each other in that manner. All right, so let's take a look at page 842. Let me erase this. There. Oh, I missed a spot right there. Got it. Okay, 842, numbers 7 through 12. What we're dealing with here is to find the 6 trig functions of each of these triangles. So let's just look at one. Let's look at number 10 because it's kind of cockeyed. So we got there's the right angle. This is the reference angle. This is S. I think that's an L, but I can't tell for sure, but we'll call it L. And we'll call that one M. Okay, so, and they call this angle 1. So the sine of angle 1 is equal to S over M. The cosine of angle 1 is equal to, well, I should use that capital there, not to confuse it with a 1, would be equal to L over M. And the tangent of angle 1 will be equal to S over L. So those are the 3 main ones. These are the 3 that you would use in your calculator as well. And then, of course, the inverses of those, cosecant of angle 1 will be equal to M over S. Secant of angle 1 will be equal to M over L. And the cotangent of angle 1 will be equal to L over S. So those are the 6 trig functions for this triangle right here. Now, the next group there at the bottom of page 842, there's a group for number 13, there's 4 triangles. 14, there's 4. 15, 16, there's 4 triangles for each group. Now, what they want you to do is determine which of those triangles has the same measurement for angle A. Okay, so let's look at 13. A. So we're dealing with a tangent function here because we have angle A as a reference angle. So let's see, that's a small one. Angle A, what is that? 2 and 1. And then B, I'm not going to draw it out the full size. This is angle A, and 6 and 3, and then the next one, oh, that's terrible. I should stop doing it right now because every one of them I draw is getting worse. That's 3 and 4. Then the really small one, the smallest one of them all. Yeah, that was a joke. This is angle A, and this is 0.5 and 1. Okay, so all of these would be tangent functions because they're the opposite the opposite and the adjacent sides. So let's look at the ratios. So we have 1 over 2. Is that equal to, or is it not equal to 3 over 6? This fraction right here, 3 over 6, reduces to 1 over 2. So yes, these two angle A's are the same. Well, let's look at this one. 3 over 4. No. This angle A is not the same as these two angle A's. Well, let's look at this one right here. 0.5 over 1. Yes, this is a 1 to 2 ratio. 1 to 2, 1 to 2. So all three of these are 1 to 2 ratios of the opposite over the adjacent. So therefore, this one, and this one are all the same. This one is something different. Okay, so let's look at, I want to look at number 14. So, yeah, because that's got something different there. So we go, there's the first one, right here. 3, let's see, that's a 4 and a 3. This is angle A. And then the next one, I'll just draw it down here. Oh, that's a terrible triangle. This is angle A. They give me, this one is 6 and this one is 8. And then they give me a small one. Angle A, 1.5 and 2, is it? Yep, 2. And then the last one is this one is angle A, and 1.5 and 2. Okay, there's a couple of different ways we can start this. I'm just going to compare these two for right now, or these two, it doesn't matter. Let's compare these two. Angle A is here and here. That makes this the opposite side for this triangle, and this the opposite side for this triangle. So opposite, this is going to be a tangent function because we're dealing with opposite and adjacent. Also here, opposite and adjacent. So I have to ask myself, is 4 over 3 equal to 2 over 1.5? All right, if you don't know, we can cross multiply. So 2 times 3 is 6. Does that equal, yeah, it does. 4 times 1.5 is 6. So yes, this angle A and this angle A are the same. Oop, I got out of screen a little bit, sorry. This angle A and this angle A are the same. Well, let's compare these to this one. Okay, so here's angle A. This is my opposite side, my adjacent side. So I know that these two ratios are the same, so I'm just going to pick this one. So opposite over adjacent, 1.5 over 2. Is that equal to 4 over 3. Now, you could cross multiply this and try it, but that they're not the same, because this is an improper fraction and this is not. These cannot be the same. This is going to be bigger than that one. So this angle A is not, so this one and this one are the same. This one is not the same as those. Okay, well, now let's talk about this one right here. Okay, well, we're not even given the opposite side here. Now you can find it by using the Pythagorean theorem, but let's examine what's going on here. This is my reference angle. This is the hypotenuse here. 4 over 3 is the same as 8 over 6. But this is not a tangent. This would be a cosine. Well, actually, it would be a secant. Because for a cosine, it's this side over that side. So this angle A is not the same as these two either. Well, for the main thing is they didn't give us the opposite side here.